Hey YouTube, thanks for visiting. Hope all you are doing well. So in this session, we already also solved some questions of modern algebra. Okay, so this session is helpful for the upcoming CSIR net exam, and this is the question practice session on modern algebra. Okay, so in the previous one lecture, we also take the questions of modern algebra, and in this class, we also solve some questions of modern algebra. Okay, and I also take some question practice class on real analysis, so you can also watch the video. In this videos are on the channel page. Okay, so now start this lecture, and before starting I am requesting you to all those who are new in my channel, please give a like to this video, share with your friends and subscribe the channel. Okay, so I make a request that I make in my channel more than 330 videos, but many of you are watches my videos but do not subscribe the channel, so this is very bad thing. Okay, so this very demotivates me to make such videos, so please subscribe the channel. Okay, so now we start. So these are the questions of last lecture, so this is the questions of today's lecture. So it says that, and one more thing is that the questions are not only from CSIR net, there are questions of CSIR net, and I make one, I think one questions here, and some questions are of one and two questions are of CSIR or NBHM. Okay, so let G be a group of order n. Which of the following conditions imply that G is abelian? Okay, so here we use the tricks that if G is a group of order PQ, where P and Q are prime and P is less than Q and P is not equal to Q, okay, where P and Q are primes, then if P does not divide Q minus 1, then we know that the group G is what? It is cyclic, and a cyclic group, hence this is abelian. Okay, and if this P divides Q minus 1, then either G is cyclic or non-abelian. Okay, so these two cases occur here. Okay, now if we see for n equal to 5, so 15 is equal to, we see clearly here that 15 is a product of 3 and 5. If we choose P equal to 3 here and Q equal to 5 here, as P less than Q, so and P not equal to Q obviously, and here we see that 3 does not divide 5 minus 1. Okay, that is 3 does not divide 4. That means this group G is cyclic and hence abelian. Okay, so option A is clearly correct here, and since this is a part B question, so you don't need to check the remaining options whether it is correct or not. Okay, so this is very easy questions, and also whether you want to check, then you can check for this 21 equal to 3 into 7, and 3 divides 7 minus 1. So this 21 order का जो group होगा वो cyclic हो सकता है. If cyclic, then it is implies abelian. If non abelian, then it is not abelian. Okay, so दो केस यहाँ पर occur कर सकता है. So ऐसे तो नहीं बन सकते, मतलब यहाँ पर बोला है abelian ही होगा. ठीक है, so this is not possible. Okay, similarly we can write this 36 as 2 square into 3 square, I think. Okay, so 2 square into sorry, this 36 we can write this 36 is a group of order 36 which can be D18. So D18, we know that this is a group of order 36, and we know that D18 is not abelian clearly. So this maybe there exists a group of order 36 which is not abelian. So okay, so this is not correct, and ये जो ग्रुप है, so this is n equal to 18. a कैसे नहीं हो सकता है, so देख लो एक बार. So 18 equal to, we can write 2 into 3 square. Okay, now here we apply another one concept. Okay, so if order of G equal to P square into Q, and Q does not divide P square minus 1, okay, so then this implies G is abelian. So this is a direct result. You can remind this result. If order of G is equal to P square Q such that this one Q does not divide P square minus 1, then G is abelian. And here there is no restriction on P and Q. So if we choose here p equal to p square q, so 3, and q is equal to 2. Now q is equal to 2 here divides your 9 minus 1, which is 8. So 2 divides here 8. So this is not happening. Okay, so that's why we cannot say that this is abelian. Okay, so this is also false option. Okay, now next question. So next question is, let G be a group. Suppose that order of G equal to p square q, where p and q are distinct prime numbers satisfying q is not congruent to 1 modulo p. That means what? Q minus 1, okay, does not divides p. Okay, sorry, p does not divides q minus 1. Okay, so p does not divides q minus 1. Okay, so now which of the following option is true here? So if we take the example first, so if we take a group such that order of G equal to 45, which is equal to 3 square into 5. Okay, so this is of the form p square q, where p square q, so p equal to 3 and q is equal to 5. So q minus 1, that is q minus 1 is 4. So 3 does not divide 4. That is, these conditions is satisfied. Therefore, we can choose a group of order 45. Okay. Now option 1 says that G has more than one p silo subgroup. So we have to find the silo 3 subgroup. Okay. So number of silo subgroup यहाँ पर बोला है option A में it is more than one. Now to find the silo subgroup, we know that 1 plus 3k types होगा, which divides the 5. Okay. So 1 plus 3k divides the 5. Now the possible values of k is only 0. Since k is only 0, then 1 divides 5, we take k equal to 1, then 4 does not divide 5, k equal to 2 means 7 does not divide 5. So that means in 1, this is equal to only this. Matlab 1 plus 3 into 0, this is equal to 1. Okay. So the number of silo 3 subgroups here is 1. Okay. So this is false. Okay. So you can discard these options by taking this example. Okay. So now if we take order, so I tried these questions by taking the orders, but I get the order here. If we take the order like this, 11 square into 5. Okay, so this is p and this is q. Okay, so you can see here 5 minus 1, this is equal to 4. Okay, and 11 does not divides this 4. Okay, so this conditions is satisfied. Okay, so now we have to find in option B silo p. Okay, so silo p means silo here, silo 11. Okay, so 1 plus 11 silo 5 subgroup. So we first see option D here. Okay, now okay, so we first see the option D here. Okay, now silo q here, so 1 plus 5k must divide 11. Okay, so if we choose k equal to 0, then obviously we get n1 is equal to 1. If we choose k equal to 2, then we also get n2 is equal to what? 1 plus n2 means k equal to means 11. Okay, so here we see that the number of silo q subgroup, okay, maybe 1, maybe 11. And here पर option D में बोला है has a unique silo q subgroup. So no, it is not unit. It may be unit. It may be more than one. Okay, so option D is again a false one. Okay, now option C, we see that the number of silo q subgroups of G is divisible by p. Now silo creep, the number of silo q. So silo q here 1 plus 5k, that means divisible by p, where p is equal to this one 11. Okay, so 1 plus 5k also we can also this write as 121 because this is the product of 11 square into 5. Okay, तो ये जो होगा k का वैल्यू 24 होगा, मतलब यहाँ पर n का वैल्यू जो होगा 24, but 11 does not divide 24. Okay, so sorry, this is very silly mistake. So that is, this is also not correct one. Okay, so option B is only the correct one. Okay, now go to the next question. The question says that let S7 denote the group of permutations of the set 1, 2, 3, 4, 5, 6, 7. Then which of the following is true? There is no elements of order 6 in S7. So we write this 7 to the class equations and take the GC LCM of these products, elements of these sums, and find whether that we get the LCM 6, 7, 8 or 10. Okay, so this is the main motive to solve the question. Okay, so 1 plus 1 plus up to 7 times एक हो सकता है, ठीक है. Then we can write this is 1 plus 1 plus 1 plus 1 plus 1 plus 2. This is one class equation. 1 plus 1 plus 1 plus 1 plus 3. This is one class equation. 1 plus 1 plus 1 plus 4. This is one class equation. 1 plus 1 plus 5. This is one class equation. 1 plus 6 is one class equation and 7 is one class equation. Now LCM of this gives LCM is equal to 1. LCM of this element, that is LCM of 1 1 1 1 1 2 is equal to 2. So we get 1 order element, we get 2 order element. So this is equal to LCM equal to 3. So we get 3 order element. Here we get LCM 4. So we get 4 order element. Here we get LCM equal to 5. So we get 5 order element. We get 6 order element. We get 7 order element. But there is no element of order 8. And we also get 10 order element. From here we can write 2 plus 5. So LCM of 2 and 5 gives 10. So this is also exists. So this is true statement, this is true statement, this is true statement, but this option there is no elements of order 8 in S7. Okay, the next question is, let G be a simple group of order 168. Okay, then what is the number of subgroups of order G in 7? Okay, so since G is a simple group, okay, so that means we find here the silo 7 subgroups. Okay, so now we find here 1 plus 7k. Since 168 is equal to, we can write 7 into 2 cube into 3. Okay, 8, 24, 7. Okay, so now 1 plus 7k must divides these others. So this is 24. Now if we choose k is equal to 0, then n1 is equal to 1. If we choose k is equal to 1 2 3, देखो और किसी का वैल्यू के लिए ये नहीं होगा. If we choose k is equal to 8, only in that case 56 57 sorry, if we choose k is equal to 1, right, if we choose k is equal to 1, then 8 divides 24. Okay, so that means we get n2 is equal to 8. So see, we can get a subgroup of order 1 and subgroup of matlab silo subgroup of orders 7. Okay, orders number of silo 7 subgroups, number of silo 7 subgroups is either 1 or 8. Okay, but it says that it's a simplet group. But if we take silo 7 subgroup is 1, that is unique silo 7 subgroup, this implies normal, and this implies normal, that means this is not the case of simple group. Therefore this is the only case when we get the simple group. मतलब यहाँ पर जो है सिंपल ग्रुप दिया है, दैट मीन्स यहाँ पर इसका कोई नॉर्मल प्रॉपर जो है नॉर्मल सब ग्रुप नहीं रहेगा. ठीक है, सो दैट मीन्स दिस इज द ओनली पॉसिबिलिटी. ओके, सो 1 तो नहीं होगा, जो ऑप्शन जो होगा करेक्ट होगा वो होगा 8. ठीक है, नाउ नेक्स्ट क्वेश्चन, लेट पी बी अ prime number, the order of a silo p subgroup of group GL50ZP of invertible 50 by 50 matrix with entries from ZP equals to. So this is clearly a formula based question. So the formula or the notes is, let G, that is this is equal to, if we general linear group of order n by n matrix over the field FQ, that is Z. Okay, then the number of QSSG, Q silo subgroups, number of Q silo subgroups equal to Q to the power n into n minus 1 by 2. And if this is SL NFQ, then the formula is also same. Okay, so mind it. Now we put here just p to the power, here the value of q means p, so p to the power n means 50 into 50 minus 1 by 2. So this is equal to p to the power 50 into 49 over 2. So p to the power 25 into 49, which is equal to 5 9 45, so लास्ट में जो डिजिट होगा उसका 5 होगा, एंड वी नो दैट दिस प्रोडक्ट इज 1 2 2 5. So the correct answer is option D. Now last question is of today's class. What can be the class equation of the non-abelian group of order 12? So see, it is non-abelian. So first option 1 plus 1 plus 1 plus 1 12 times. It is not possible because this is a class equation in case of an abelian group. That is for Z12, like you can say. Now it says that now we can take this is a non-abelian group of order 12 means the group is D6. Okay. So we have to find basically the class equation of D6, and since here D6, that is Dn and n is n even, then what is the class equation? If we remind this, so the class equation is obviously 1 plus 1 plus n by 2 plus n by 2 plus remaining are 2. एंड देखो यहाँ पर एक फॉर्मूला है कि क्यू कितना नंबर ऑफ 2 मतलब यहाँ पर होगा, बट you don't remind that because you just write 1 plus 1 plus n by 2 means 3 plus 3 and remaining 2 up to the this sum is equal to the order of the group. Okay, so 1 plus 1 means 2, 2 3 is 2 plus 3 5, 5 plus 3 8, 8 plus 2 10, 10 plus 2 12. So this is the class equation. Directly you can say that is the option D here. Okay, so this is the questions of today's, I think, yeah. So these are the questions for today's class. If this sessions is helpful for you, if this sessions is helpful for your preparation for your question practice, then please give a like to this video, share with your friends, and don't forget to subscribe the channel. Okay, so thank you, bye bye, मिलते हैं अगला वीडियो में. Thank you.